Hey everybody, how was your spring break? It probably wasn't very much fun, was it? I went snorkeling in the rain. All right, let's review what we were doing before spring break here on probability rules on two-way tables, shall we? Woohoo! All right, so the first thing we learned was or, right? These are your mutually exclusive events. Or, remember the saying, more with or, more with or, all right? It covers a lot of space, which is good and bad in that you will overcount with or. All right, so the formula looks like this, probability of A or B. Or means to add, so we take whatever A is, we add it to B, but after you do the addition, there was more with or, so you subtract the overlap. The overlap is the intersection between A and B. All right, so let me grab a different color. So we're minusing that overlap. All right, so I've got a sample two-way table for you right here. This is a researcher who was curious about people being able to tell the difference between apples and potatoes when their nose is plugged and their eyes are closed, right? Take a bite. Does it taste like an apple or potato? I think I'd be able to tell the difference, but some people could not correctly identify it. Anywho, here are some examples of reading the probability off of this two-way table. What is the probability of eating an apple or correctly identifying? All right, so you start with the first event, which is apple. How many people ate an apple? Looks like 34 ate an apple out of 80. So 34 out of 80. Or means add, so now we'll add the next piece. Correct. All right, so how many people correctly identified what they were eating? It looks like 68 out of 80. All right, then we have to watch out for the overlap. So let me do a little circling here. We've got apple, we've got correct. So the overlap is 30. So we're gonna subtract 30 out of 80. Now, when you're dealing with fractions and the denominator is the same, all you have to do then is focus on the numerator. So 34 plus 68 minus 30, that leaves us 72. So the answer here is 72 out of 80. All right, 72 out of 80 chance that you're eating an apple, or you guessed correct. You could always turn that into a decimal if you want. So that would be a 90% chance, right? 0.9 or 90% chance. All right, let's look at, oh, I totally have this in the wrong spot. See? Check it out. It says mutually exclusive, and this is overlapping. And what did I just do? I just did overlapping. So I'm going to have to do a little switcheroo. All right, so this is an example of overlap. Mutually exclusive. Okay, mutually exclusive is when two events are an or problem, but they do not overlap. So in this table, an example of mutually exclusive would be apples and potatoes. Right? Because you're either eating an apple or a potato, you're not eating the same, like you're not eating both of those at the same time. Or you're either correct or you're incorrect. You can't be both. Okay, so mutually exclusive events follows the same formula, but there's no overlap that you have to worry about. For example, probability of eating an apple or potato. All right, so you start with the first event, apple. We had 34 apple eaters out of 80. Potato, we have 46 potato eaters out of 80. And when you analyze these two events, apple is this top row, potato is the second row. They don't share any overlap, right? They're in two separate rows with nothing being circled twice. So there is no overlap. There is minus, I'll put a little zero here, right? There is nothing to worry about, no overlap. So when you add these up, 34 plus 46 turns out to be 80. So there's a 100% chance, according to this table, that you're either eating an apple or a potato, right? 100% chance. Okay, so those are your or probabilities. The other thing that we learned last week were the and probabilities. These are your intersecting events. So it would look like this: probability of apple and correct. All right, so notice I'm kind of stealing this one. The only thing that I changed is the word and instead of or. All right, so and is more restrictive. And asks you to only look for the intersect. So apple and correct. How many people ate an apple and correctly identified? 30. 30 people out of 80. So the intersection is 30 out of 80. So the and problems, they don't have any algebra involved. You're just looking at the chart and you're grabbing what you need off of the chart. Another example of and, how about probability of apple and potato? All right, so when you look at that chart, apple and potato, what's the intersection? There isn't one, right? They're in two separate rows. There isn't a number that would be intersecting between that. So this would be 0. All right, let me give you one more. How about probability of correct and how about potato? All right, so correct and potato, correct and potato. The intersection between those two events is 38. So 38 out of 80. All right, so or problems require some work. You got to look at those totals and add it up and minus the overlap, or sometimes minus no overlap. Whereas the and problems, you just look for the intersection and you're done. All right, and then the last thing we saw before spring break was conditional. Conditional probability, that's when you narrow down the, that's not how you spell denominator. Denominator. Instead of being out of 80, this grand total, we're going to narrow it down. So for example, what is the probability of eating an apple given you correctly identified what you're eating? Okay, so after the slash bar, that's your denominator, right? We want the correct down here in the denominator. All right, so how many people were correct? We had 68 people that were correct. So this is going to be 68. So out of those 68 people that were correct, how many were eating an apple? Let's see, 30. 30 people were eating an apple. So our answer is 30 out of 68. So your denominator changes with given, right, when they want you to narrow it down. Let me give you another one with words instead of symbols. What is the probability of eating an apple if you incorrectly identify? Alrighty, so the given piece that we're going to focus on, because if is another keyword that you might see. So if you incorrectly identify, so that's going to be our denominator. So out of the incorrect, let's see, there's 12. 12 people were incorrect. So out of those 12 people, how many ate an apple? 4. 4 out of these 12. So there you have it. Conditional events narrow down your denominator, your sample space, instead of using the grand total of 80. Ors is when you add up and you subtract overlaps. And is when you're looking for the intersection in the two-way table. All right, so try the practice worksheet and send it to me on Edmodo.